Consider the following formula. Which of the following statements is true for this formula? To solve this question, we're going to need to graph this equation so we can analyze the relationship between t and r. Normally, we would identify a cause and effect variable and label our axes accordingly. However, there are answer choices that have both t and r as causes and effects. So that means it truly does not matter which way we label our axes. There's no best practice for labeling them. So I'm going to label y as t and r as x and continue from there. If you would like, you could rewrite the expression to say y equals 1 minus x now that you've chosen which variables represent x and y. If it's easier to just look at familiar variables, but for the sake of the video, I'm going to keep things in terms of t and r. So to find our t-intercept to start the graphing process, we need to let r equal 0. So we'll rewrite our expression, t equals 1 minus 0 instead of r. T equals 1 minus 0 is just 1. So our first intercept point is at 0, 1. Then to find our r-intercept, we need to let t equal 0. So instead of t, I'll write 0 equals 1 minus r. Then opposite operations will add r to both sides, and that will give me r equals, this cancels, leaving me with just 1 on the other side of the equal sign, and that rewritten as a coordinate point is 1, 0. Let's plot these 2 points. Over 0, up 1 would put me right here, and then over 1, up 0 would put me right here. We can connect these 2 dots and have our graph. Now notice when we look at our answer choices that there are no options that talk about a specific point on the graph. There is no when t is less than 3, r is positive, nothing like that. We are just dealing with t as a whole being positive and r as a whole being positive. So this means we need to think about this in terms of our quadrants. Let's start with quadrant 1 and quadrant 3. Quadrant 1 is when t and r are both positive. And quadrant 3 is the opposite, where t and r are both negative. Now before we move on to the rest of our quadrants, notice that there are no values for the graph in quadrant 3, meaning whatever answer is referring to quadrant 3 is incorrect. And that would be answer choice D, saying that they are both negative. Then quadrant 2 and quadrant 4 are also opposites of each other. Quadrant 2 is when let's do t first. T is positive, but r is negative. And quadrant 4 is when t is negative and r is positive. So now we can look at our answer choices with this information. A says if t is positive, r is negative. And this is implying r must always be negative when t is positive. So let's see if that's true. In quadrant 2, it is true because t is positive and r is negative, but we also have a small portion of the graph that is in quadrant 1, which means that t and r are both positive. So A is incorrect. B says t and r may both be positive. This word may says that for some portion of the graph it may be positive, and that is true with what we just talked about. In quadrant 1, there is a small portion of the graph, a small portion of time when t and r are both positive. So B is our correct answer. But let's be absolutely sure and check C. C says if r is positive, then t is negative. That is talking about quadrant 4. And while there are values in quadrant 4, again, we still have some values in quadrant 1, meaning that t is not always negative when r is positive. Sometimes when r is positive, t is also positive. So C is not correct, making B our correct answer.